Our lesson for today is about basic electronic components and equivalent schematic symbols. We start with resistor. A resistor is an electronic device used to limit amount of voltage and current. It means that this device or this electronic component is used in opposing the flow of current and voltage inside the circuit. So it can limit or regulate the flow of voltage and current inside the circuit. Now the kinds of resistor. The first one is fixed resistor. We call it fixed resistor because this type of resistors contains definite amount of resistance. The basic and it fixed resistor is the one used for the basic symbol of resistor. Okay, so be mindful of the basic symbol, schematic symbol for resistor, fixed resistor. The first example is a Phillips type resistor. Okay, so Phillips type resistor is basically the sizes is based on its wattage. The higher the wattage, the bigger the actual component. The physical appearance is bigger than those with lower wattage or power rating. The next one is cement type resistor. So basically, cement type resistor has higher wattage. So it means that its physical uh, appearance is larger or bigger than those of in Phillips type resistor. So this time, the specification of this component is printed on its body simply because the body of this resistor is big enough to write the specification of this component. On the other hand, for Phillips type resistor, its value is color coded. So it means that you need to convert the color codes before you can read or get its resistance value. The last one on the list is an SMD resistors or a surface mounted resistor, and they are also called chip resistor. So these chip resistor are the smallest resistor because this one has no terminal. So the terminal is basically attached to its body, and its value is basically coded. So you have to convert its code to get its value. So surface mounted, it means that it is directly soldered on the surface of the printed circuit board. The next kind of resistor is a variable resistor. It is called variable resistor because this type of resistor, its resistance can be varied. Okay, it can be changed from its minimum value up to its maximum value. So having its symbol, so the basic symbol of resistor added with an arrow. Okay, so when you see an arrow across or attached to the basic symbol of resistor, it means that it is a variable resistor. So the first one is a trimmer resistor. Trimmer resistor is basically used in adjusting voltage and current inside the circuit. The next one is a potentiometer resistor. Okay, the first component you see on the screen is a slide potentiometer. Basically, this one is used to adjust volume. Okay, this is used for volume controls, like on mixer. Okay, the one that is used by the DJ, and the other one is used on controlling audio or sound. So both of these components are used in controlling sound, mainly on amplifiers. The next one is a symbol for rheostat. Okay, so rheostat basically is a resistor used to control motor, or it is used to control the speed of motors. Under the kinds of resistor, we have the thermistor. Thermistor is a temperature varying resistor. So it means that its value varies with temperature. Okay, so take note of the letter T on the variable resistor symbol. Okay, so these are the example components. So be mindful of the components because uh, this is also similar to diode, capacitor, and other components. So the symbol is very important because this one will tell you that you are dealing with resistor, the kind of resistor which is thermistor. Next one is a light dependent resistor, or LDR. So as you can see on the symbol, there are two incoming arrows. It means that this type of resistor varies with light. So it either um, lessen or increases the amount of resistance in the circuit depending on the application of light. The next one is capacitor. So capacitor is an electronic device having two or more conducting plates or terminals separated by an insulating material called dielectric. Why is it that this component or this material is called dielectric? Dielectric because uh, it, it has two functions, either blocks or absorbs current and voltage. So mostly, this dielectric material is made up of insulators. Example of this are paper, ceramic, air, and electrolyte solution. Basically, what I mentioned here, or what you can see on the presentation, are the most common dielectric materials used in making a capacitor. Kinds of capacitor. So we have the polarized capacitor. When we say polarized capacitor, this capacitor has polarity. So when we say polarity, it means that it contains positive and negative. And when mounting on the circuit, you need to observe the positive and the negative terminal of the capacitor. Okay, the first one is a tantalum capacitor. Okay, these are the samples of tantalum capacitor. It may come in any color. However, the construction is like this. Uh, it's like an oval shape. No? Be reminded of the length of the terminal. Okay? The longer the terminal, it indicates that the longer terminal indicates that that is a positive, or that is the positive terminal of the capacitor. The same with electrolytic capacitor or the aluminum type capacitor. Okay, the longer the terminal, it means that it is the positive terminal of the capacitor. So when the capacitor terminals are already cut, so you will be uh, or you can use the markings on its body. Okay, the black markings shows that it is the negative terminal of the capacitor. Under the kinds of capacitor, we have the non-polarized capacitor, or the capacitor that you can mount on the circuit without looking at polarity. So as you can see on its symbol, there is no polarity symbol, no positive, no negative. It can be mounted uh, the way you like it. Okay, the first one is ceramic capacitor. So basically, it range with a maximum of 50 volts. Next, mylar capacitor. Its capacity is up to 250 volts. And the last one is a polyester capacitor, which voltage capacity can be more than 630 volts. As you notice, the bigger the body of the physical body of the capacitor, the higher is its capacity to stand amount of voltage. Next one is variable capacitor. So variable capacitor again will show you an arrow crossing the basic symbol. Okay, there it is. A tuning capacitor. So variable capacitor is mostly used on varying frequency. So since capacitance greatly affects frequency of or frequency of a signal, so capacitor is used as tuning capacitor or used on tuning your favorite stations on televisions or on uh, radio station, your favorite radio station. Next is diode. So a diode is an electronic component or device that allows the flow of current in only one direction. What are the different types of diode? First one is rectifier diode. The rectifier diode is the most common diode or the general type of diode which is used in converting alternating current into direct current. So the basic symbol is used on rectifier diode. So you have the anode and the cathode. The bar is the side that indicates negative or negative side of the component. Okay, there is its equivalent representation of component. The band or the silver band indicates negative side of the diode. The next one is LED or the light emitting diode. Again, the diode symbol plus two exiting arrows. It means that it is a light emitting diode. It emits light. That is why the arrow shows exiting arrows or going out arrows. Zener diode. It is represented by an inverted Z. So as you can see, the bar, again, on the arrowhead, indicates that it is the side for negative electrode or the negative terminal. Okay, Zener diode are mostly made up of silicon or made up of crystal. Okay, the bar again indicates that it is the negative side of the diode. Next one is a photodiode. So this one is an opposite of LED. Since LED is emitting, the photodiode accepts light. So the arrow is, there are incoming arrows as part of its symbol. Okay, so photodiode. So the function of this diode varies with light. Another type of diode is a varistor diode, or they also call it varactor diode. As you can see on the symbol, it is a combination of a diode and a capacitor. So basically this component is used to protect the circuit against overvoltage. Next one is a tunnel diode. A tunnel diode, as you can see on its symbol, it's like its bar on the arrowhead looks like a close, or you are entering a tunnel. Here is the actual component. Basically, this this component is durable, and this one is used for pass switching in computer. The next one is pin diode. Pin diode is a combination of positive materials, intrinsic materials, and negative materials. When we say intrinsic materials, this is a semiconductor materials without impurities. It means that it is a pure semiconductor. Here is the equivalent symbol. Take note of the pin on top. So it means that when you see the pin on top, this diode, this component is referring to a pin diode. Okay, so it's made of crystal. The component is made of crystal, and this pin diode is used for high frequency operation. The last one is the laser diode. I know that you are all familiar with laser diode. So basically, the symbol looks like a diode with a double bar. Okay, and the arrowhead, the two arrows are going out. Okay, these are the example components. Okay, so laser diode is basically used in electronics application on DVD, fiber optic, barcode reader, etc. It can also be used on medicine and some other application in the industries like cutting of metals. Our next component is transistor. Transistor is an electronic device that performs switching, amplifying of signal, and as current regulator. The following are the transistor outline. The TO92, or the small signal transistor. TO220, or a transistor with metal top. And TO3, the biggest and rated as power transistor. Types of resistor. Generally, we have two general types of transistor, the NPN and the PNP type transistor. We start with NPN type transistor. So the only difference between the two is that the construction of this transistor is from negative, then positive, then negative material. So positive material is sandwiched between collector and emitter. So the base of this transistor is positive. The indicator for NPN transistor is the arrowhead going out. So take note of the arrowhead on emitter terminal that is going out. On PNP transistor, the negative material is sandwiched between emitter and collector. So it means that the base is a negative material. Emitter and collector are positive material. And this time, the arrowhead on emitter terminal is going in. Okay? So again, these three type of transistor outline can be an NPN transistor or a PNP type transistor. Next component is IC or integrated circuits. Okay, the following are the different symbols or schematic symbols for integrated circuits. Any components with three or more terminals or three or more uh, connections indicated means it refers to integrated circuits. Other schematic symbols used in electronics and electricity. First one is antenna. So, I guess you are all familiar with the symbols or symbol on your cell phone. Okay, these are the different schematic symbol for antenna. Transformer. So this is the symbol for a transformer. A transformer uh, is an electrical device used either to step up or to step down the amount of current and voltage. On the other hand, antenna is used for collecting signals. Okay? It's used for collecting signals that will enter the circuit. Okay, so this one is the physical component or physical appearance of a transformer. Next is microphone. I hope that you are all familiar with microphone component and you need to be familiar with the microphone symbol. Next one is speaker. So I guess the speaker is one that is easy to remember. Another is Puce. Okay, so there is the symbol for Puce. So Puce is basically used for protecting the circuit or the device against overloading. Okay, so this one is a Puce. Next is coil. Okay, so there is the schematic symbol for coil and the actual coil. Coil is actually made from wire. So not just an ordinary wire, but a magnetic wire. Okay, and then uh, rule on wires. So if you see a loop, no, a loop or a jumping loop on intersection, so it means that the wires are not connected. The same with an intersecting lines without a small filled circle, it means that the intersecting lines are not connected or wires are not connected. And lastly, in an intersecting lines, when you see a small filled circle, it means that there is a connection or the two wires are connected. This ends our lesson for today, okay, on basic electronic components and its corresponding or equivalent schematic symbols. There are a lot more electronic symbols, schematic symbols. There are these digital components and symbols. The same with the different switches. Since we have a lesson uh, in switch, we will just take the different schematic symbols for switch in our next lesson. So have a good day and Pax et Bonum.